we're really excited to have Erin Kennedy here today from Robot Missions. We do a bunch of typical robotic stuff. Also a robot, this is like a brand new thing for Auto Civic Tech. And so yeah, so we'll do Erin's presentation, and then after that we'll go to our sort of usual Civic Tech traditions of a round of interviews, projects that are on the go, and take it from there. So thanks so much to Erin Kennedy for being here today.
Alright, so thanks everyone for joining in here. I think this is going to be a project that if you're into Civic Tech stuff, you'll probably be interested in this. The only difference is that this is involving a bit more robots. So my name is Erin Kennedy, as Sean mentioned, and I'm the CEO and technical founder of Robot Missions. At Robot Missions, we're helping the planet using robots. So what on earth does this mean? Well, we have a video that will sum it up pretty well. So here it is. So that lets you see a bit about the robot in action. We've actually brought it out on 20 field tests across Toronto and Ottawa. And at field tests, we bring in participants from the community to get hands-on experience with interacting with the robot, and more importantly, understanding the pollution problem firsthand that we see here locally. So the specific problem that this robot is addressing is the pollution challenge. We're aiming at debris that is between 3 to 25 millimeters. That's typically the debris that you don't see with your own eyes when you're on a manual cleanup effort. How this is currently addressed is with large machinery, which is typically noisy, a little bit intrusive because it's such a large machine, and it sometimes doesn't pick up that small size debris. And again, with manual efforts, we tend to ignore it because it's so small, hard to see. And it comes at no surprise that cities do spend a lot of time and money trying to address this problem. Here in Ottawa, there was a statistic shared that the city of Ottawa spends $5.5 million and over 112,000 hours every year cleaning litter. That's things that are like cigarette butts that we should clean up in order to prevent the cigarette butts from harming our ecosystems. So where Robot Missions comes into play is to enable cities to be able to increase their productivity for their crew. Imagine being able to deploy robots like these onto the beach to autonomously and efficiently collect the debris and then be able to recycle it afterwards. Along the way, collecting a repository of data of both the environmental sensors as well as where the debris is located and what type of debris. This would form hotspot areas that we could see in order to target the efforts in the specific areas that need to be addressed the most. Finally, the most important and fun part, which is probably what would resonate most with all of you, is the active citizen engagement. So that's getting the public involved with this. So how do we deliver onto our solution? We have three main ways, which is the robot platform, the Bowie robot that you see here, as well as automation services. You could think of this like apps, but for a robot as applied to the environment, as well as environmental stewardship. So the robot platform is designed to be lightweight and portable. If you could imagine, you don't need a machine to transport a machine. That's what we're going for. I brought this on the bus from 7 Bayview and at the Innovation Center to come to here. So you don't need to have like specific machinery to be able to move this around. If you need to go to another beach within your city or a park, then you can just bring it with you. It's quiet operation. If you're really quiet right now, you can hear it sort of humming a bit from its servo motors. That other hum is the HVAC. And it's powered by rechargeable batteries, lithium polymer batteries, the type that you would find in a drone. And for those of you that have seen it or have a keen eye to this, it is all 3D printed, which means it's easily extendable and repairable. No longer would downtime have to mean like weeks waiting. It would have to mean how many hours until this print finishes. It's less intrusive than the large machines, so quite a bit of a smaller footprint. And of course, it's open source. Open source software for the firmware, and open source hardware for the electronics and CAD models. So the automation services are what we're imagining the apps of robotics to be like. So imagine you could say something like, Bowie, clean up the shoreline until 4:30 p.m. And then it would use the shoreline cleanup app to be able to do this on a shoreline. Eventually there will be even more, such as baseline assessments, as well as some in environmental restoration and air quality monitoring. Environmental stewardship comes into play during our public field tests. And this is really where it gets hands-on, and it invites everyone to be a part of the process of testing this robot. So that way it shows that citizens can use this. This is a tool for all citizens to be able to help make it more efficient to clean up our planet. So we currently do this as well with our Adopt-A-Bot program, which is where we rent out the robot to schools, as well as workshops that we do in schools where we show the process going from a prototype to a much more polished version, so the various stages involved. And for those who want to replicate the robot, they're able to do that with the files. I touched on this earlier. So the vision of robot missions is to be able to democratize robotics for citizens to be able to tackle these challenges. So if you could imagine one day, maybe you're at a library and you want to be able to take your robot or take a robot out for a spin at the park to be able to do your part of community service to clean up the shoreline. This is one of the ways we would envision that being possible. The progress that we've done so far has been through 20 field tests where we've had 250 participants at these. At our final one for last year, which was at Westboro Beach, we even had 40 people join in, including Councillor Jeff Leeper, which was great. The robots collected 3.1 kilograms of non-natural debris, and so if you could imagine, this type of debris is quite lightweight, as well as during the 20 field tests, we were always continuously improving over various iterations of the robot. So we expect this number to go up quite a bit throughout this upcoming summer, when we'll actually have this a bit more stable platform to use. Robots traveled 1,200 meters, and 5 robots in the world have been replicated. We even have one replicated in upstate New York, Rochester, New York. So what we're imagining one day is it'd be cool to surround the entire Lake Ontario, the perimeter of it, with robots. We've done workshops with the Canada Sci-Tech Museum, Girl Guides, SHAD, and also in partnership with Queen's University. What's been super cool recently is that the University of Ottawa Engineering Design class has actually chosen our robot to use as a platform for their introductory design class. So we have 100 students making their own modules to extend the functionality of the robot into environmental restoration. So far we've seen modules being created to spread wildflower seeds in order to increase pollinating plants. We've seen modules that will be able to take water quality samples and use that to be able to have some samples that are reported in the format of the new open data standard for recreational waters. It's led by Swim Drink Fish, which is an initiative partnered with Lake Ontario Waterkeeper, which is great. And there's 100 students, which is just amazing, using this as a platform. So no longer is it just mission number 1 of shoreline cleanup, it's now also mission number 2 of environmental restoration. So as you saw in the video, it was a dramatic reveal of these municipal trials. What does this mean? Well, we have started to work on this idea of deploying 3 robots onto Westboro Beach for the duration of the entire summer. We've received authorization from the city to do this, not only on just Westboro Beach, but also Mooney's Bay Beach, which is just amazing to think about. So in specific zones on these 2 beaches, we'll be having robots rove and navigate autonomously to be able to pick up this debris, collect data, as well as just be useful to test our robots in the field continuously. And this is where we need your help. So what we're looking for are volunteers to be able to help get the robots to the beach, observe how they work, and then get them back to either where you're staying at or to the Innovation Center. And the name of that volunteer role is the Robo Wranglers. So it's such a cool name, and it will be such a cool role. So you should definitely volunteer to help out. We have some data already where it's maps air quality data to GPS waypoints. And it would be good to explore different mapping technologies to be able to possibly extend this to other beaches in the world, or even maybe provide a live update of what is happening here in Ottawa as we get the data back in from the robots every day. And yes, visualizing the robots' data. So if it sees debris, then maybe have like a cool web page where it would show an indicator of how much debris it's found and collected. We're also looking for sponsorship connections to be able to help make the municipal trials a reality. So we've been awarded a grant through the Ontario Centres of Excellence to start the trials, but now we have to find the matching funds in order to do this. And so if anyone knows any corporate sponsors that would be interested in this from the standpoint of corporate social responsibility, it'd be great to know about that. And then finally, join us on a field test this summer. We'll have the robots there, and it'll be great if you can help pick up some pollution as well when you're there alongside the robot, and just watch how the robot works and evolves. So to sum it all up, at Robot Missions, we believe we all have the duty to preserve our natural spaces, and we're on our way to making this happen together as a nation using robots that are accessible and replicable. So thank you.